Hello, today we'll be looking at the interannual bumblebee abundance, which is driven by indirect climate effects on floral resource phenology. This article is included in the Ecology Letters and it was published in 2017. Bees are pollinators which serve as an important ecological function for the reproduction of plants for fruits and flowers. Bee populations are declining worldwide, and this could lead to an ecological crisis. Bumblebees in particular, or bumbus, are eusocial insects where the population is directly linked to the abundance of flowering species. This study focuses on 3 species of the Rocky Mountains. Due to rising temperatures from climate change, bumblebee populations and plants in this area have shifted to higher altitudes to acclimate to colder environments, and flowering have shifted to earlier in the season. Not only are the temperatures rising, this area has experienced earlier spring snowmelt and more frequent spring frost. We will explore the effects of these climate changes in this study. In this study, we will be looking at the indirect effects of climate change on bumblebee population abundance and the direct effects on floral phenology. Phenology is the study of changes in the timing of seasonal events such as budburst, flowering, dormancy, migration, and hibernation. As you can see by this figure, climate directly affects flower phenology and indirectly affects bee abundance. This study gathered data for 8 years, from 2009 to 2016, and was compared to the past data of the Rocky Mountain Biological Laboratory. The data of the bees took into account the tongue's elevation, size, and abundance, while climate took in the temperature, snowmelt, and precipitation. And with flowering, they took into account the species and the phenology. The number of visitations of different flower species were recorded at different elevation sites. Piecewise structural equation modeling, or SEM, was used to perform statistical analysis where the distribution curves were fit best by Shipley's test of d-separation. There is a variation in the peak abundance of the 3 species with an increase of visiting flowers during high threshold flowering days, which is about 14 to 30 days of the flowering season. B. bifarius saw the highest peak abundance with 0 to 17 bees caught per hour and 60 to 897 flowers visited per floral season. B. flavorfrons had longer floral days, about 5 to 6 days longer than the other 2 species, and 0 to 13 bees were caught per hour and 36 to 850 flowers visited per floral season. B. oppositus with only 0 to 8 bees caught per hour and 811 flower assemblages visited per season. As you can see by this figure, precipitation and snowmelt had a significant effect on floral days, which affected bee abundance. There was an increase in bee abundance with more floral days when the floral days were above the floral threshold, which is about 0.75 meters squared. But with low floral days below the floral threshold, negative effect on bee abundance can be seen. The study found that there was an increase in the number of floral days with more precipitation and earlier snowmelt, about 13 days earlier. There was also an increase in the number of flowering days, about 20 more days than recorded previous, but 6 to 12 of these days were of low flower threshold. As you can see by this figure, the number of snowmelt days shifted earlier and the number of floral days increased. Precipitation changes were inconsistent between the years. Rather than direct climate effects on bumblebee abundance, indirect effects were found correlated to these bee populations from climate change on the flowers these bees forage from and thus pollinate from. Indirect effects from the study show that with increased temperatures, flowering seasons are lengthened, which may lead to increased resource gaps of low flower threshold and deteriorate the bee populations long term. This can be from a starved queen or insufficient resources to grow a colony. The lower flower threshold is indicated to be due to damaging spring frost and/or drought due to high temperatures. Our altitude bees also have a limited time to forage, which is normally around 10 weeks but is reduced with higher elevation. Direct effects concluded from other studies is that foraging can be reduced with increased precipitation and temperature, and in extreme temperatures, increased mortality of the bee population. Snowmelt dates also affect queen emergence times to initiate a nest. All these factors have contributed to a reduction in the bee abundance of the Rocky Mountains over several years. Researchers indicate the need to study the ongoing effects of climate change on bumblebee populations, the effects of resource gaps on bumblebee populations in various climates, and the effects of climates on florophenology that may be species specific. A study by the Ecosphere Journal in 2016 found that in 2007, due to increasing temperatures in the Rocky Mountains, flower phenology shifted earlier while bumblebee phenology stayed the same. As a result, bumblebees and flowers had a mismatch of species interactions, which led to a reduction of resources for bees and a reduction of bumblebee populations. The study compared data from 1974, and there was a reduction in bee abundance from 1974 to 2007. As you can see by this figure, there is a reduction in the number of bees in 2007 at almost all elevational regions, compared to the number of bees in 1974 data. This is similar to the study we have discussed, which was studied from 2009 to 2016, but this study explores the direct effects of flower phenology on bumblebee populations rather than the indirect effects from climate change we have seen. Here are some fun facts about bumblebees. For more information about what you can do to help, visit environmentamerica.org.